Good day. So we are Group 1 C. We are here to report about our topic, manual radar plotting. So course MTEC 102, period semifinal, week 1, session 1. Topic, manual radar plotting. So the following members are Aligado Vinceiros, Aseo Charles Matthew, me myself Basco Denny, and Bation Fair John Lois. So the course outcome is the manual plotting techniques given the information from the radar observations. Learning outcome, at the end of the session, the student shall be able to comprehend the history of maritime navigation radar, determine why radar is such a valuable tool, and recognize the ship parameters. The importance of the topic is the students can perform the manual plotting techniques given the information about the radar observations. So, history. So, new technologies of radar became available to merchant shipping with the end of hostilities in 1945. So, the opportunity arose with the end of hostilities in 1945 to make available to merchant shipping in the new technology of radar, which has developed so rapidly in the secrecy of war. So radar on merchant ships was initially installed for commercial purposes, so on ferries to maintain better schedules in fog and large fishing vessels. So the year was 1942. Radar technology was developed during the Second World War, but it all took off following a decision that from 1942, all US and British commercial vessels had to be equipped with radar to improve the safety of navigation as well as to enhance the detection of enemy ships. It took quite some time until radar became commonplace on merchant ships of other flags. So radar was treated with great suspicion by the mariners, of the day, and was usually the preserve of the master, who lacked it so that it could only be used when he was on the bridge. So ports also started using radar for the commercial purposes of berthing ships in fog. One of the example is in the port of Liverpool in 1948. So the next reporter will be Venzeros Aligado.
Next slide, please. Improving technology, and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of number of serious collisions at sea. The International Conference of Safety of Life at Sea in 1960 revised the international regulations for preventing collisions at sea by adding new rules to, to take account of the use of radar and recommendations on the use of radar information as an aid to avoid collisions at sea. International Conference on Safety of Life at Sea in 1974 adopted provisions to SOLAS Convention, making a radar mandatory carriage requirement for merchant ships in a phased program during the start of 1980, which finally completed in 2002. SOLAS requirements. All merchant ships of 300 gross tonnage and over now shall carry a radar, and many carry two. IMO adopted performance standards for marine radars, which are used in connection integration with other navigational equipment required to carry on board ships, such as automatic tracking aid, ARPA, AIS, ECDIS, GNS, and others. Non-SOLA ships. Many small craft, millions, also carry radar voluntarily, as manufacturers have produced cost-effective designs for their needs. So the next reporter would be Aseo.
The ship master's points of view. The key facts are the radar remains and will remains the primary system of pollution avoidance, and radar is very important tool for navigation. Why is radar just such a valuable tool? The master and watchkeepers have confidence in information radar provides because its operation is ship-based. It's not reliant on third-party sources. It has a proven track record. Radar is useful with search when engaged in search and rescue. In short, in its display, radar offers the watchkeepers the base reality of all targets relative to the ships. It therefore aids the watchkeepers and helps in decision making for both navigation and collision avoidance. Collision avoidance. Oh, the next reporter is Bati.
So, good afternoon, everyone. I am Cadet Pution. And collision avoidance. Early action is required to avoid a close quarters situation. Therefore, early identification of closing targets is essential. Watching keeping Watchkeeping officers need to be competent in the use of radar and are trained in its use and the application of ARPA. Next slide, please. Some IMO requirements. Maximum emergency stopping distance from full speed of the ship should not be more than 15 ships length. Emergency turn radius of the ship should not be more than 2.5 ships length. Next slide, please. Ship's parameters. Speed is up to 25 knots. Length. Largest container ship is 335 meters. Capsize bulker, 300 meters. Panamax, 220 to 230 meters. Next slide, please. Emergency stopping distance, 3.3 kilometers to 5 kilometers. 1.8 nautical miles to 2.7 nautical miles. Emergency turning radius, 550 meters to 840 meters or 0.3 nautical miles to 0.45 nautical miles. Displacement weights, 100,000 to 250,000 tons. Practical requirements. To start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles off. Next slide, please. Radar gives accurate information on distance from charted features and assists in maintaining the ship's course. Radar will normally show a 60-meter high landmass at a range of 20 miles. This is considered by seafarers as a minimum requirements. Next, reporter will be Cadet Basco.
So from our presentation, so this is an example of the radar, which is a S-band, which is north up. The north up is turned on, the relative motion, and it has overlay, which is yellow. So next is one of the example of an X-band radar. As you can see, it is different from the S-band. Are the differences between S-band and S-band, X-band and S-band. So target description, its features, the shorelines, and the detection reading in nautical miles, the typical navigation buoy. So these are the differences between them. Determination of targets from a watchkeeper's perspective. So to be able to distinguish a tug from its tow at sea at 12 miles range. So approaching a rig on a supply vessel to clearly identify the standby boat from the rig at 6 miles range, and to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. So this is one of the example of a tugboat connecting to the vessel. Surveying tugboat in a oil rig, and a coast guard passing in the special mark buoy. So the next reporter again will be Cadet Aligado.
Resolution MSC 19279. 5.5.1 range. The radar system should be capable of displaying 2-point targets on the same bearing, separated by 40 meters in range, as to distinct objects. 5.5.2 bearing. The radar system should be capable of displaying 2-point targets of the same range, separated by 2.5 degrees in bearing, as to distinct objects. So the next slide would be the examples of radar ARPA. Navigation. Radar greatly assists navigation during poor visibility. Pilots rely on radar at close range and reduced visibility to pass buoys and beacons. These are the examples of. Next reporter would be Cadet Aseo.
Sources point MSC 0.91 and 192. 5.4 minimum range 5.4.1 with on ship at 0 speed and antenna height of 15 m above the sea level and the calm conditions. The, navigational buoy in table 2 should be detected at minimum horizontal range of 40 meters from the antenna position and up to a range of 1 nm without changing the setting or control function other than the range scale selector. Engineering terms, point ITU and R M.13 power 13 minus 70 kilowatts. Horizontal beam width 0.75 minus 4 degrees. Volts with 0.03 minus 1.2 microsecond. PRF 4000 minus 375 HC. News figure 3 minus 8 dB. Pitch 3 degrees. Roll 25 degrees. L 50 degrees, 5 degrees. So vertical beam width 20 minus 30 degrees. This is the X-ray band radar and stern band radar.
This is the example of WP8P 2001. Next slide, please. So this is the example of a navigational the pilot house. Next slide, please. That's all, and thank you.